Hey, hi everyone. This is Sai from Let's Upgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us, like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
All right, students. Hello, everyone. So up till now, what we have got to learn is that in C++ language, we have learned about basic introduction of the C++. Then we have got a short introduction about arrays and strings. I have told you these are one of the two most important topics of DSA, and we are preferring to practice it as much as possible. So, in the continuation of that, right now, let's just get started with one of the practice question. Let's just practice one of the question to get very familiar with C++, how a program works. Okay, it's going to be a pretty straightforward one. Let's see. Our question will be write a program to take input marks of 5 students and then print the average of that. As simple as that. You have to simply input five numbers, five integer values, which are going to represent marks of some students. What we have to do is we have to find the average of those. Okay, so I hope all of us are very aware about the formula of how to found an average. Okay, here what we're going to learn is here we're going to know is that is how to use array in these kind of questions and how to take input. Okay, let's just get started. Before starting anything, a very good general practice would be here. I'm just letting you know that how you should approach a question. It is not the very important question, but in this question, I'm letting you know that how you can approach a question in an interview, in an exam, anywhere. Whenever you have faced a question, the very first step would be there are going to be a couple of steps which I'm going to assume that everyone is going to follow. First step is obviously going to be understand question very well. That is obviously going to be the very first step. Okay. Second step would be to build a logic. Here, this question is pretty straightforward. Here, you just have to do what has been told in the question. So there is no logic involved here. Although there is going to be formula, but still there is not much of a thinking process that we are going to do in this one. But there are going to be plenty of time that you're going to spend on building the logic. Okay. Once let's suppose your logic is built, you are aware about how you're going to approach a question. Now it is very important to write down those steps. What exactly you're going to do in a question. Those steps are simply called as write down pseudocode. That is one of the very important step that we have. Okay, and once that is also done, then the very last step would be to write down code. Let me just let you know here is in this third step, along with writing down pseudocode, another step is also involved. That is the most important one, which is dry run. If you're not aware about what dry run is, you should be knowing it because dry run is simply what makes programming programming. That is, when you are aware about the steps, when you found out a solution, and then now you have to write down the actual process using pen and paper, not using computer, not by typing anything, but actually writing down rough in your rough notebook using pen and paper. That is very important, using pen and paper. Programming is always and always happens on pen and paper, never on the computer, never on the system. Only coding happens on the system. Okay, there is a huge difference. In coding, you simply write down the code what you have been told to do. In programming, you found out the solution, and that to do that, you have to write down something which is going on through your mind. That is what pseudocode and dry run is. So, according to let's just follow our steps. First step would be simply understanding the question. We understood the question very well. We have to input the five integer values, five numbers, and then we have to find the average of those numbers. As simple as that. Let's just do that. You understood the question? Second step is building the logic. Logic is pretty straightforward here. That is, you just have to apply the formula of finding the average of five numbers. As simple as that. Third one would be writing down the pseudocode. Let's just do that. Because it is a very easy question, pseudocode is going to be pretty straightforward actually. Okay. Let's just say first step is create an array. This is what pseudocode is. When you're writing something in English, using a sentence, in a short sentence, just giving you the idea, giving others the idea that what you're going to do exactly. First step would be creating an array. Once you have created the array, next step for you would be iterate using a loop. Inside that loop, 2.1, what you're going to do is input five numbers. I'm writing down exactly what we're going to write down in the code. So in the same format as well. So make sure you are also following the same thing. Once you have input the five numbers, what you have to do then is when you want to find out the average of five numbers, you need to have sum of those five numbers, because formula for average would be sum of five numbers divided by number of items, correct? So you again have to iterate using a loop, and inside that loop you have to find sum of five numbers outside the loop. Now you have done the process. You're coming outside the loop. Now what you will do is simply apply the formula, and at the end you can simply print. Either print the answer or you can return the answer, whatever you find. An answer is simply as simple as that. These are the steps what we are going to follow. You will be able to look at the code, and then looking in the pseudocode, that you will find out that these are exactly the same things what we are going to do in the code. So let's just go to the code quickly. So if we are writing down code, our first step would be, obviously, first step was in pseudocode creating an array. So let's just do that. We're going to create an array, ARR. Let's just call this as ARR, which is going to be of five size. As simple as that, because it is, we are well aware that it is going to be of five size only. Then let's just iterate a loop and then input those five values. I hope you are aware about that, how you use a loop. If not, you can just watch the previous video. So we are iterating from 0 to 4 in the loop, so that it will run five number of times. Every time you're going to have ARR of I, and inside it you're going to input a value. How do you input a value? Using cin, as straightforward as that. You are well aware about that. Once your array is completely built, now you have the values in an array. What you will do is, next step in our pseudocode would be to iterate again in a loop and then find the sum. Well, you might have a question that why exactly we are using two loops when we can do the same thing in one single loop. Well, yes, you are right that you can do it in a single loop in this question, but in your future there are going to be many other questions which it is not going to be possible. So we're going to keep a better practice to have a separate loop when we are trying to input something. Okay, whenever you're inputting something, just try to make a separate loop out of it. You don't need to do the multiple things in the same loop, and that is not going to change your time complexity at all. So don't worry about that. That is not an issue. Okay, let's just create a variable sum, initial value with 0. Run a loop from again 0 to 5, and keep adding values, current value, in that sum variable. Once that loop is completed, you have done the addition, and now you can simply apply the formula. That was the next step in our pseudocode. Okay, what is the average? Let's just create a new variable. No issue in creating multiple variables. That will make your code much simpler and easy looking. Okay, sum divided by 5 is going to be your new value. At the end, you can simply print the average. One thing you might notice here is that I have created an average variable of int type, of integer type. Well, that is not a very good solution going to be, because what if the average comes in decimals? So that's why in that case, I'm going to just say create this variable as either float or double, whatever you like. Now your answer will be appearing in decimal values. Okay, let's just input any random 5 values. Let's just say 1, 2, 3, 4, and 5. As straightforward as that. So let's just give it a run. And when we are running it, it's printing the answer as 3, which must be the average of these 5 numbers. Correct? Let's just put another input to make sure that your answer is coming as correct only. If I use all 5 values, average should be 5 only. If I run it again, yes, average is coming as 5 only. So yes, it is giving the right answer. Great. Let me just put this code in the notes. Now you can see, if I zoom in, you will be able to see I have followed the exact same steps. Creating an array, yes, right here. Iterating using a loop, yes, right here. Input 5 numbers, absolutely right. Iterate another loop, right here. Find sum of 5 numbers, right here. Apply the formula, right here, and then print the answer, right here. Pseudocode and code is exactly the same. Only difference is one is written in English, other one is written in actual code. Just make sure you are writing down all the notes and all the code that I'm showing you. Let me just zoom out and show you the entire code, entire page. Here is the question. Steps that is expected in every question, not for this particular question, in every question. Pseudocode is written here, and then the actual code is also there. Okay, just make sure you write it down, and then we will move to the next topic. Okay, I hope you must have written it down. Let me just create a new page. Our next topic here is simply this is one algorithm that we use in arrays concept. So here we are just getting started with algorithms in array. And obviously later on we're going to have it in strings as well. So let's just name this topic as algorithms in arrays and strings. Our first algorithm which we are going to learn in this one is linear search in an array. Okay. Before moving to linear search, what exactly is searching according to you? Obviously, it is pretty straightforward. We have been searching lots of things in lots of websites a lot of times. Searching is simply finding a specific element or a specific object throughout the process. That is what searching is, as straightforward as that. Now, why exactly it is called as linear search? Okay, because this is actually one of the brute force method that we use while we are doing searching. That is why it is called as linear, because actually it takes linear time in searching an element in obviously the worst case scenario. Now what exactly do I mean by that? What do I mean by it takes linear time? Well, time should be in either milliseconds or second or minutes or hours, like that. If you are not aware about time complexity concept, then let me introduce you to that as well. Then we will go to linear search as well. Let me show you an example. Because right now we are talking about arrays only. So let's just try to search something in an array. So let me just draw an array first of all. It is much easier uh, when we are writing down in notes while talking about something or while thinking something. That's exactly what I wanted to tell you when I'm saying that you should write down the notes as well. Whatever I'm writing down right in front of you, You should be writing down in your notes when you are practicing something or solving a question or even in an interview. If you're not aware about this, but you will be definitely allowed use of using copy and pen when you are applying an interview, when you are in an interview solving a question. Interviewer will never tell you to do not write this or do not do something using pen and paper. No, a, a, a true interviewer will always allow you to write down while you are thinking. No matter, they might allow you to write down using your copy pen, or they might allow you to write down in the screen itself. That is totally up to them, but they will definitely allow you to write down things when you are thinking of the process, when you are trying to solve a solution. Lots of interviewers like me, when I have taken interviews, every time I always see that if student is writing down something when he is talking about the process, in most of the cases, if you're not writing down anything while explaining something, interviewer might assume that you're cheating. You might be looking from somewhere, you might be using AI or anything like this. But when you are writing down things, when you are talking about a process, then that time interviewer will believe that yes, you are thinking about the solution from the scratch on your own. That is why it is very very important to use copy pen, or either you can write down in your notepad or in the system as well. That is totally up to you where you are writing, but it is very very important where you are, very very important to at least write down something. Okay, anything, it could be anything, it is totally rough. So as I was saying, here I have created an array. Let me just give this array indexing as well. As I have already told you, array is array does have indexing concept, and it always starts from 0. So because this array indexing starts from 0 go till 8, you're all aware about the size of the array, right? What is the size of the array? It is not 8, it is 9. Very good. So let's just say I have written some of the random values inside an array. 5, 3, -2, 0, 7, 700, 8, 90, 20, -1. Any random values will be okay. This is the array that is given to us. Now what? Another thing which will be given to us is a target. What exactly you're looking for? What is the thing that you're searching for? Let's suppose our target is uh, 890, or let's just say it is -1. I am going to say, let's say it is 20. This is our target. This is what we are searching for. Now, in a concept of linear search, okay, I think I was talking about time complexity, right? Yeah. So, what I wanted to say is that when you are searching for a target could be anything at all. In linear search concept, you always starts your searching from the very beginning, and then you check that is this the value, is my current value, which is 5, is it equal to my target? It is not. Because it is not, now you will go to the exact next index, and then check the exact same thing, that is this the current value equal to my target? If it is equal to your target, then very nice, you have found the solution, you have found the answer, you can simply end your process right here right now. But if it is not, so you will simply discard that index, and then you will search on the next particular index. It is again, you will again check, is it equal or not to my target? If it is not, keep searching on the next index. It is again not equal, it is again not equal, again not equal, again not equal. Now is it equal to your target? Yes, this time it is exactly equal to my target, and you can simply say I have found the value that I have been told to find. And right here, right now, you can simply end your process and destroy your program. You may simply return the values from your program and end the process. Now, I was saying that why exactly is this called as linear search? Let me tell you that. Let's suppose in this example only. Target could be literally anything. Okay, target could be literally anything. We have a best case scenario, we have an average case scenario, and we have a worst case scenario. That means in the best case scenario, let's just assume your target is equal to 5. Let's just assume your target is equal to 5. Now, when you are applying the searching process, you will always and always start from the 0th index. Yeah, that means the very first index, as I just told you. Whenever you go to the first index and you check if this the current value exactly equal to your target, yes, you will simply say yes, it is exactly equal to my target, and you will simply say end my process and finish the program. Now tell me, how many operation does it took for you to find your solution? You found your answer. Well, I would say you have checked your current value with your target only one time. Number of operations is equal to 1. Could you have any less number of operations in any possible case? No. This is the very first value, and you cannot have better than this number of operations. This is the best case scenario. That is why this is called the best case scenario. That means the least number of operations you have to take while you are trying to find your solution through this linear search. What about this one? Let's suppose your target is -1. Then what? Then you will do again, start from the very beginning. Process will always remain the same. You will start from the very beginning. You will check if your current value is equal to your target. It is not. You will go to the next one, and the next one, and the next one, and the next one. You will be keep on going exactly like this till the very end. If you are going till the very end, that means what is the number of operations you have took? Number of operations you took. Well, according to me, you have compared your current value with target one time here, then second time here, then third time here, then fourth time here, then fifth time here, sixth time here, seventh time here, eighth time here, ninth time here. That means you took 9 number of operations while trying to find your solution. At the very end, you will find your solution, you will find your target, and you will end the program. Can you have any more number of operations possible in this scenario? You cannot. That is the maximum number of operations that you can take while applying a process. True. That is why this is called as worst case scenario. And then you can assume any target in between for an average case scenario. Let's just say 7 only. The middle one. What is the number of operations you took? In that case, obviously you took something half, something 5 number of operations. Every other case apart from these two, worst and best, you will assume it as average case scenario. That is why this is called as linear search, because you are searching one by one in every single element, and you have best case scenario, average case scenario, and then worst case scenario. As simple as that. Why have I told you about this process? Why exactly have I told you about this process, that how many number of operations it is taking? To tell you about the time complexity, as I said. When you are talking about how much time a program took, you cannot, obviously, as a human, you cannot tell the number of millisecond it took to get executed, unless you have a machine. That is why Whenever it has been asked to us that what is the time complexity of your program, of your process, that time you give an approximate idea using a variable that this much time it took. And when we are talking about time complexity in big O notation, we always tell about the worst case scenario. This one. We always and always talk about the worst case scenario. How do you tell the time complexity? Whenever someone asks what is time complexity, in short I said TC, time complexity. Big O, that's how you write it down. Big O, and then in bracket, what is the number of operations it took? It is actually 9. But you cannot write down an absolute value here. You cannot write down a number here. I told you, you have to use a variable. The 9 is what exactly? As I can see, 9 is the size of your array, which is 9. Size is 9 is the size of your array. And if you think about it, you can have multiple arrays and every array can be of different size. If that is true, that means uh, the size of array could be anything at all. That is why we cannot say there is an absolute number or an absolute value which we can write down inside big O. That is why what we always assume is that inside big O, we are going to assume we have a small n. I have used a variable small n as my to represent my time complexity. Whenever you are talking about time complexity, you always have to mention that what exactly is n. So let's suppose I am an interviewer and I asked you, you have write down and explained about the linear search program. What is the time complexity of that program? You will always say something like this. The time complexity of my program is big O of n, where n is the size of the array. Let me just write it down. Where n is the size of array. Because array size could be anything at all. That will be given to you in the question itself. That is why you will always say that n is the size of my array, and that is what my time complexity is. And this is what you call a linear time complexity. This is what you call a linear time complexity. This is something very, very important. And I would prefer if you write down all of these things in very, very details. Right now, you have understood the concept of linear search, and you have also understood the concept of time complexity, also its scenarios: best case scenario, average case scenario, and worst case scenario. All three scenarios you understood now, right? All right, great. Just make sure you write it down in your notes in very detail in a proper manner. Then I will move on. Now I will simply move on to actually writing down the code for our linear search. All right then. So now let's just write down the code for this concept. We will practice code using a simple question. Okay. Let me just write down the question first of all. Our question here is write a program. WAP is simply short for write a program. Write a program to input 5 numbers and also input a target. Exact same requirement for linear search. And print the index. That is what our question is. We have to print the index at which our target is present. Else print -1. That is what our question. Just look at the question first of all. Obviously, first thing would be to input some numbers in an array. Let's just say 5 numbers in an array. And then we have to also input a target. Same requirement for linear search. Then we have to traverse through it using linear search, obviously, because we have learned linear search, and print the index at which our target is present. Okay. If you are unable to find any target in an array, unable to find your target in an array, then you have to simply print -1. That is what our first step according to our logic, what we have learned just now right here. Understand the concept, understand the question. We have understood the question right now. Now we have to build a logic. There is no logic involved here because we are using algorithm here. And you have know this algorithm because I've just told you about the linear search. Now, write down the pseudocode and then do a dry run. Okay, let's just do that. First of all, what I will do is simply use the exact same example to explain this question. I'm going to name this array as ARR. Let's just assume the name of this array as ARR, short for it, array. Because our question says to input 5 numbers, so let's just assume we have this much array only. And now what? Now we have to input the target. Let's just assume our target is -2. Or let's just say 7 only. This is what our target which we have inputted. Now, let me just tell you how you will do the dry run of any question involved when you are practicing something. Let's just say this is the input what you have and the target and the array, and you have assumed these are the indexes in your array. Write down the pseudocode first of all. You think about it. What is the first step that you have in your pseudocode? Obviously, let's just write down the completely create and input values in array. Then next step would be obviously input your target value. That also includes within the pseudocode itself. Then what? From right here, it will start your logic. What you will do is iterate in array using loops. Obviously, using the loop only, you will be able to iterate in an array. Inside this loop, what exactly you're going to do? Obviously, the very first step would be to check that is the current value which you are on. Let's just assume you are on the very first index. Is this the value exactly equal to your target? So let's just write it down. Check if current value is equal to target. Okay. Let's just assume it is equal to a target. In that case, what you will do? 3.1.1. You will simply say print index. Let's just say print current index. Next step would be 3.1.2 is to simply stop your process. In case you found your answer, then you have to simply break the loop and stop the process. Then come outside the loop. If it is not equal to your current target, you will just simply keep on going in your loop. This loop will be keep on going. And if it is equal, it will simply break and you will come out of the loop. Okay. Fourth point would be here. Check if some value is printed. If some value is printed, that means you have definitely found your answer and there is nothing else you need to do. If there is no value printed, that means you are unable to find your target, and then simply print. But exactly according to question, print -1. And that's it. That's where you can simply end your process. Let's just do a small pseudocode, right? Sorry, let's just do a small dry run. Let's just assume, according to your dry run, you are starting, according to your process, you are starting your process from the 0th index. That means your ith value. Inside the loop, you have the value I, right? Let's suppose I value is at 0. At I equal to 0, you will simply check if this current value 5 is double equal to your target 7. No, it is not. Just keep on going. Then you will move to the next index I equal to 1. Here also you will check if your current value 3 is double equal to your target. No, it is not. You will keep on going. Then you will move to the next index I equal to 2. You will check right here, is this current value equal to your target 7. No, it is not. You will simply keep on going. I equal to 3. You move to the next index. Is this current value equal to your target? No, it is not. You will keep on going. You will check at I equal to 4. Is this current value equal to your target? Yes. Right here you found out the current value is equal to your target. That's when you will simply print. Print what exactly? The index, which is I equal to 4. This is the value which you will print and simply end the process. That is what a small dry run will look like. Always make sure to write down these things whenever you are practicing. So if you understood the concept, let's just write down the code as well. Let's just use the same this much part. Let me just remove this part. Okay, I'm using the same array of 5 size, iterating 5 number of times to input all the values in the array. Let's suppose that is done. First step of the pseudocode is completed. Next step would be to input your target. You can simply say cin target. Once your target is also inputted, now you have all the required values present. Next step is iterate through your loop, iterate through your array, which is of 5 size. And every time inside this loop, check if your current value, what is your current value? ARR of I. That is what your current value. Is it equal to your target? Let's suppose if that is true, look at the pseudocode again. Then you will do is simply print your index and break the value, break the loop. What exactly you're going to print? See out. What exactly you're printing? You have to print the index according to the question. So you will print I value. You will print the value I. And let's just go to the next line using enter. And very important part here is to break the loop as well. So to stop the process. If you don't do that, it will just keep on going till the end of the loop and it will take lots and lots of time. Now at the end, what we have to do is we have to check if you have at least found a value or not. For that, what we'll do is I will simply create a flag of boolean type, of bool type. Here I will simply say it is false right now. If you found something and you have entered inside the if condition, you can simply change the value of that flag to true. Now outside the loop, if you can check, if you say your flag is double equal to true, that means you have found some value and you don't have to print -1. In case it is still false, that means you have never entered inside this if condition, and you can simply say print -1. That's it. That's where you can simply end your process. Let's just try to write down this. Let's just say I have, let's just use the exact same example, okay? 5 3 minus 2 0 7. 5 3 minus 2 0 and 7. Also you have to input the target, which is 7, let's suppose in this case. If I run, you will see that you have printed the correct index, that means 4, at which your 7 target is present. Let's say instead of 7, if I say find 10, which is not present in your array. If I run that, now it will simply print -1, indicating that this particular target is not present in your array. Let's just take this code to the nodes. I'm going to save it in the next page. I have included the input and output as well. Here is your code. So now if you have understood the concept of array, let me just also introduce you right now to the concept of string manipulation. First of all, you should be simply aware about what string is, that you are already are. Let me write down one example, short example again. A, B, C, D, or literally anything else inside the double quotes. This is what you call a string, which is what I have told you the definition. Definition of your string is collections of characters, as straightforward as that. All of these are simply characters. If you combine more than one characters in a single pack, it will simply be considered as a string inside a double quotes. Okay. As I have told you, string also have a concept of indexing. So whenever you have written down any string at all, it will always be and there will always be an imaginary number which will be considered as the indexing. Now, because of the previous class, you are aware about how do you declare a string, how do you how do you update a value, update a character in a string, how do you get a character out of the string, or how you can remove it as well. So that basic things you are totally aware about. Other thing is also there, that is you can simply manipulate this string as well. That means you can change its value, you can change its order, and you can arrange it in a different ways. That is what you call string manipulation. One very straightforward example of string manipulation would be, let's just say you want to reverse a string. You simply wanted to reverse a string. Let's just assume this string, this particular string, is given to you as an input. Now what you have to do, your answer should be reverse of this string. That means if you output something out of the program, it should look like this: D D C B A, like this. And to be very honest, it is a pretty straightforward task. It is a very straightforward task that you can do. Let's just try to do that. Okay. The question right here is, write a program to input a string and print the reversal of that string. According to our logic, there are 4 steps in total. You have to understand the question, you have to build the logic, you have to write down the pseudocode and dry run, and then you will finally go to the coding part. Before moving to the question, one thing I just remember is, I forgot to tell you that how much time you should spend on each of those steps. If I just go back to our main page right here, here I've told you these 4 steps. See, it's a very general practice. It's a very general thing that how much time you should spend on each particular step. That you will get to know by practicing a lot. But because I have been practicing for many years now coding, so I can just simply tell you that what you should do is, let's just assume you have 1 hour. I'm just taking a reference. Let's just assume you have 1 hour for one particular question. What you should do in that case? First of all, you should spend at least 5 minutes to understand the question. That will give you a better idea what exactly question is. Do not be afraid of spending time on understanding the question. Just take some time. Do not just quickly read the question and directly jump to the coding part. That is a wrong approach. Do not take 1 second, 2 seconds to write down the question to understand the question. No, take 5 minutes, read the question twice, understand it properly, and then you will get to know what exactly you have to do. Then I will say next 5 minutes you can spend on building the logic. Think about it. Think about the approaches that you have. Think about the different questions you have practiced. Using that, create an approach, and then move to the most important part, which is this one. Most important part, which is dry run. Do not be afraid on spending all 50 minutes on your dry run. That's how important dry run is. That is why I have taken this reference to tell you that which part is the most important one. Take maximum time, almost entire time on the dry run itself. Not only when you are practicing, but also when you are inside an interview, explaining to the interviewer what exactly you are doing. Take the full time, take the entire time on the dry run itself. Lot of time this even happens that when you are dry running some particular concept in a very proper way, interviewer might not even ask you to write down the code. Interviewer will be simply impressed or simply understood that you know the concept, you understand the concept properly, and you do not need to write down the code. Because if you have spent lots of time on the dry run, if you have taken at least 3 examples and dry run on those 3 examples completely from start to end, completely, I'm focusing on that part, completely dry running from start to end on at least 3 examples, interviewer will understand that you do not need to write down the code, because after that you will just need maximum 2 minutes on the coding. Let me tell you a very strange thing, that if you have spent 50 minutes out of 1 hour on the dry run, Even if the code is of 100 line, you will not take more than 2 or 3 minutes to write down it, because in after that, after the dry run, you will need only one single go to write down the code without changing even a single character. That's how important dry run is. Okay, all right, get back to our original question. But our question was, we are trying to write down the program, we are trying to input the string, and then printing the reverse of that string. We understood the question. Let's just write down the pseudocode. I'm pretty sure most of you will simply, what you will do, that short thing that come to your mind, let me tell you. Input a string is the first step in your pseudocode. Then what? Then I think most of you, what you will do is iterate in a string from start to end. Sorry, iterate in the string from end to start. And then inside it, you can simply print each character one by one. Print each character one by one from start to end. That's it. That is the entire pseudocode, as straightforward as that. That is very, very straightforward thing. Nothing special. What you just need to know is what is the, how do you get the exact character which you are, that you are already aware about. How do you get a character? Let's suppose if I am on this string, if I am this input string, and I want to access this particular D, how can you do that? How can you access this particular D? You can simply say, first of all, name of your string. Let's just assume it is str. You will simply use a square bracket and write down the index inside that square bracket. That's how you can simply access the character D. Print it. Once it is done, move to the previous one. Print the next character. Move to the previous one. Print the next character. Again, move to the previous one. Move to the next character. Print the next character. Done. As straightforward as that. Let's just do that. Move to the coding part and perform the exact same thing which we have just discussed. Let me just write down hash include string. You might have this question that why exactly this particular thing was not needed in the previous part, because actually I'm using the online console. When you are going to use the actual ID like VS Code or anything else, then in that case this will be very, very compulsory. Using namespace std. Now let's just do this. Let's just create or define a string and going to call it as str. Okay. Now what I will do is I will simply input a string. Let's just say C in str. I have inputted the string. It is present. Before that, let's just write it down as well here. See what exactly we are doing. Input a string. Done. Now, according to our pseudocode, what we will do is we will iterate over the string from end to start. From end to start. When we are iterating from end to start, how will we do? How will you do that? We will write down the for loop. start our I value from somewhere, then go till somewhere else, each time doing minus minus. Correct? From where exactly do we have to start? Obviously, from the very last index. What is the last index going to be? I have told you this multiple times. That is, last index of your string or an array is always going to be one less than the size of the string. Correct? How do you find length of the string? There is going to be an inbuilt function which you can use. You can simply say str dot length. This inbuilt function will tell you the length of the string by default, and then you can simply say minus one. This is going to be the last index of your string, and up till when you have to go? You have to go until the index of your string is exactly equal to zero. Keep on running the loop until this point. That's how you can simply iterate from last to start. Very nice. Every time what you should do is print the current character of your string. How do you get the current character? I have just told you, you can simply use str square bracket I. That's how you can simply get the character at the particular index. And that is it actually. Let me just clear the console. And in the input, let's say I'm saying I will input ABCD. If I try to run it right now, input a string is done. We don't need that one. Run it again. Our output is DCBA. Correct only. Let's just do that with my name. KUNAL. If I run it again, LANUK. Capital K. It is working as expected only. Great. Let me just put this code in the notes as well. Very nice. And now, if you understood that part, uh, I can simply tell you that there is one inbuilt function as well that you can directly use to reverse string as well in C++, in specifically in C++ language. And that looks something like this. Inbuilt function to reverse a string in C++. If you have any string named as str, what you can do is you can simply say reverse. All characters are small only. Reverse. In bracket, you can simply use the name of the string str dot begin parenthesis comma str dot end parenthesis closed. If you can do this, it will also simply reverse your string as well. It will do the exact same thing which we have just did. You can use this part and simply reverse it like that as well. What it means is it is using a inbuilt reverse function, and it is going to reverse the string, reverse this str string from beginning to the end. That is what we are indicating here. Inside the parenthesis, we are passing two parameters here, and we are indicating that we are reversing the string from the string dot begin to string dot end. That means from starting of the string to the end of the string. As simple as that. Let me just use this in your code as well. As you can see, if I can simply remove this loop, we have inputted the string already. I will simply use reverse inbuilt function, and then simply I will mention from where to where I want to reverse the string. I want to reverse it from s dot begin, comma str dot. Now this has reversed the string in its own, but it haven't printed the string yet. So what we have to do is we have to print the string. If I input, let's suppose ABCD only, and run it, you will see DCBA, which is printing absolutely correct, right? Let me just mention this as well in our notes. Now what I want you to do is, here in this one, I want you to try some another way of reversing the string. What you can do is, instead of printing all the characters from the very end, you can just try to create a new string. You will create a new answer string. You will create a new answer string, and you will keep on inputting the character from the end into the answer. If you not understood what I meant is, homework for you is, let's suppose if your string str is ABCD. Obviously, it has some indexes 0, 1, 2, 3. Let's just say you have created an answer string, okay, which is initially empty only. That means it is of size 0. There is no characters present inside the string as of now. What you can do is iterate in this string one by one, again from the very end only. So if you do that, your very first index that you will traverse on is going to be 3. You will pick the character from your string, answer string, from your str, input string, which will you will get as D only, and insert that character in the answer string. What will happen to your answer string if you do that? It will become D only. Pick the D and place it in the answer. Traverse on the backward direction again. You will reach I equal to 2. Pick the character. What is the character that you will get this time? You will get C. Insert that character on the right of your string, answer string. It will become DC. Correct? Again, traverse on the next element, which is going to be at index 1. What is the character you will get? You will get character B, and insert it in your answer on the right side. This time it will become DCB. Correct? Move it one more time. You are at the index 0. Pick the character which you are at. Your character will be small a. And insert that character at the right side of your answer string. What your string will become is DCBA. And once you have done from the index 0, done to the index 0, you can simply end your process and you will print your answer. That will give you the simple answer of DCBA, which is the reverse of your string. Either this is possible, or another way would be to traverse from the beginning itself. Instead of traversing from the last, you can traverse from the beginning. But instead of placing characters at the end of the string, you can place it at the beginning as well. That is one another way. What do I mean by that? What you can do is start your traversal from I equal to 0 index. What is the character that you will get? You will get the character small a. Your answer string initially is empty only. Place it on the left side of your answer. It will become character a. Correct? Move to the next index. Pick the character, which is going to be small character b. Correct? Index at index 1, your current character is going to be b. Place it, or you can say, to be exact, concatenate it at the beginning of your answer string. But that will make it ba. Correct? Right, only because we are placing at the beginning only. Beginning means at the 0th index. You can simply concatenate it using the plus sign as well. Again, move to the next index and do the exact same thing. Your index 2, what is the character that you will get in your string? At index 2, you can see the character is small c. Then again, concatenate it at the beginning of your string, beginning of your answer string. What that will do is, that will make it CBA. Correct? Correct only. Again, one last time, do the exact same thing. I equal to 3. At I equal to third index, what is the character that you will get? You will get the character D, small d. Your character will be CH, will be small d. Now again, concatenate it at the beginning of your answer. Your answer will become uh, DCBA. And then you can then print your character. All right, great. Try that on your own, and then we will move to the next part. Thank you. Let's just do one more question on the string itself without wasting any more time. Let me just write down the question first of all. Yes. So this is a very straightforward question once again. This will also we will going to perform in the exact same way. We will follow our steps with the 4 steps that I have told you before. I hope you remember those 4 steps. Each of the steps, can you just remind me once? First step would be understanding the question properly. Spend some time, read the question once or twice, and understand it properly. That is the first step. Second step would be creating the logic, creating or understanding the logic, whatever you're going to need, whatever strategy you're going to need to solve that question. Third one would be create a pseudocode and try run. Pseudocode is the exact same steps, but you're going to write down in the code itself, but also write it in the English language as well, so that it will be much clearer structure than the dry run to understand the question properly. And last one would be coding itself. All right. So let's just not waste any more time and perform this straightforward question. Let me just take an example first of all. Let's just say I have created a string str, and I'm going to say, let's suppose C small b, capital A, small a, capital B, small z, small o, capital P. Let's just assume this is the string that we have. This is the input string that we are going to get. We are just simply taking an example only. As I've told you each and every time, whenever you have either a string or an array, it will always and always going to have indexing as well. Let's just write down as well: 0, 1, 2, 3, 4, 5, 6, 7. So the size of the string right now, what we have seen is 8, because the last index is 7 itself. Okay. According to our question, we have inputted the string, and now we have to count the number of vowels in it. I hope all of you already know what a vowel is. A, E, I, O, U is the vowel are the vowels that we have. We can have either capital alphabets or small alphabets as well. The constraints that we have: string can have capital or small alphabets. Well, constraints are nothing but simply the instruction that what exactly is the type of input going to be. Input can contain what kind of things. That's what constraint tell us. Okay, so there is nothing much to do. Let's just write down the pseudocode directly. You can just take a guess what exactly our pseudocode going to be. Obviously, the first step would be input a string. Correct only. Our second step is going to be, what exactly do we have to do? We have to count the number of vowels. So we need to have a count variable as well. We need to have a variable where we are going to store the count. So create count variable. We're going to have a variable in which we are going to store the count of the vowels. Next step would be, obviously, if you want to check each and every character of a string, it has to traverse from start to end in all the characters. So let's just iterate. Iterate over string using a loop. Inside a loop, what you can do is you have to first of all pick each and every character. The character could be anything as of now, but you have to check if that character is a vowel. Let's just assume we have checked already that it is a vowel. Then inside that check, what do we have to do? Because we have encountered one vowel, that means we have to increment our count. How do we do that? We do that using an unary operator. I will let you know what that is. Increment count by 1. And then once it is entirely iterated over the entire string, you get out of the loop, and then you will simply print your count. These are going to be steps that we're going to follow to solve this question. As simple as that. I can simply show you a small dry run as well, because dry run, no matter what, no matter how easy the question can be, you should always and always perform the dry run as well. Okay, you can make it quick, but it is very compulsory to always perform the dry run. So let's just assume, according to our pseudocode, input a string that we have already done. Correct only. Then we have to create a vowel, create a variable vowel. So let's just assume we have created count variable. Obviously, we're going to initiate it from zero because initially there is no counting in up till now. We haven't counted any of the vowel. Okay. Then it says iterate over string. We are going to iterate over our string and check if each character is a vowel. All right. Let's just do that. Let's just assume I am initially at the index 0 right here. Okay. Check. Is it a vowel? What is the character that we have? What is the current character that we have? Is it a vowel? It is not a vowel. So we won't do anything and we will continue. Let's just say now we are at the next character. I equal to 1. Current character that we have is small b. Is it a vowel? It is not a vowel. Let's just iterate to the next one. This one. Current character that we have is capital A. Is it a vowel? Yes, it is a vowel. If it is a vowel, what we have to do is we have to increment the value of our count. I'm going to cut the value of 0 and make it 1. Very nice. We have simply incremented the value by 1. Moving on to the next one, I equal to 3. What is the current character that we have? It is small a. Is it a vowel? Yes, it is a vowel. Then increment the count once again. Very nice. Iterate over it again. I is equal to 4. What is the current character that we have? It is capital B. Is it a vowel? It is not a vowel. Keep on moving. Don't do anything. I equal to 5. What is the current character that you have? It is small z. Is it a vowel? It is not a vowel. Very nice. Keep on moving. No need to do anything. Now you are at the next character, index 6. Now you are at the next index 6. What is the current character that we have? It is small o. It is a vowel. So you will simply increment the value to 3. I equal to 7. What is the current character that you have? Current character that you have is capital P. Capital P, is it a vowel? It is not a vowel. Don't do anything. Once it is done, you have to simply print the value of your count. Whatever the value of your count right now is, you can simply print that. As simple as that. Very nice. Now, if we understood the concept, let's just quickly write down the code for it as well. So, according to our pseudocode, what is the first step that we have? Declare a variable string and input it. Very nice. We have done that. According to our code, according to our pseudocode, next step would be creating a count variable. So let's just do that. Int count we have created, which is initiated by value 0. Check the pseudocode again. Pseudocode says iterate over string using a loop and check if a character is vowel. We are iterating from the very start till the very end. We have iterated over the string, whatever is going to be the size of that string. Then we have to check, is this character a current character a vowel? So what we will do is, I will simply create a function. I will create a separate function to check if the current character is vowel or not. So I will simply name it as is vowel and simply pass that character here. Str square bracket I. If this value gives us true, that means it is a vowel, then we can simply increment the value of count by 1. How do we do that? We can simply say count value change to count plus 1. Once the entire process completed and you get out of the loop, then at the end you can simply say print the value of count. Done. Now there is only one thing left to create is vowel function. So let's just do that. because this function either return either true or false. So this is going to be what type? This is going to be a bool type of function, is vowel. And what exactly do we pass in this function? It is not a string, it is a character that we are passing here. So let's just accept that character C. Let's just name it as C only, or we can say CH. Here we can simply put a if condition to check if it is a vowel. Make sure you check the small character as well as the capital characters. If CH is double equal to small a, or if CH is double equal to E, or CH might be double equal to I, or CH might be double equal to O, or CH might be double equal to U. Let's just zoom out a little bit. As you can see, if any of these, if any of these condition is true, that means either it could be small a, small e, small I, small o, or small u. In that case, we can directly return true. And if that not happens, we can simply return false. Correct? But here, this condition checks only the small alphabets. Why don't we just add some conditions to check the capital characters as well? Let's just do that then. I can say or ch might be double equal to capital A, or ch might be double equal to capital E, or ch might be double equal to capital I, or ch might be double equal to capital O, or ch might be double equal to capital U. Now all 10 characters we have checked. If any of these condition is true, we can simply return true, that yes, it is a vowel. If that not happens, then in the end we can simply return false as well. Let's just try to run that and check if this particular string, let's just change it to what is the input that we have taken. Let's just use that as well, that only. CVAA, CB capital A small a, BZOP, BZOP. If I first of all clear it and run the code, we are getting the output 3. And as you can see in our dry run as well, that's exactly what we are getting as well. Here as well we are seeing our output as 3 only. So yes, this program is working totally fine. Great. Let me just add this code in our notes as well. One function is going from here to here, other one is from here to here. One thing you can note down here is that whenever you are creating a function, always make sure you declare it on the top of that function, above area only. In Java, you might declare it anywhere, up or down, but in C++, you have to declare it on the top side only. So that's why I've created it here. So I have done it. I have declared it right here. If I have done it at the bottom, it would give us the error. Please make sure to note this down. All right then. I hope you must have written it down. So without wasting any more time, let's just get started with today's session as well. I mean today's topic. So today we are going to learn about sorting in arrays. All right. First of all, straightforward definition. What exactly is sorting? It is what arranging elements in a particular order. Well, you might think that arranging elements can be of two types, either increasing or decreasing, but that's not actually true. There can be more than two ways to arrange some numbers of elements. There can be many different ways. Actually, there are a lot of going to be different ways, but all of them, literally all of them, can be solved using one simple straightforward method. Right now, we are going to talk about the very traditional sorting algorithm, but there are different ways. There is one inbuilt function which you can use to sort elements in any different order, in any kind of order. That is a little bit advanced. But before that, let's just talk about our traditional sorting algorithms. First of all, what are the types of sorting algorithms that we have? And what exactly is the difference between all those? Well, first of all, we have three most simplest and brute force basic algorithms for sorting. First three are, first one is bubble sort. Okay. Second one, insertion sort. Third one is selection sort. These three are the most basic sorting algorithms that everyone first should understand, then only move to the advanced ones. Why exactly these three are the most basic one? Because these three use the brute force method. These three use the brute force method. That means traverse on every single element to understand its concept. Okay, and these three are the most slowest one that we have. Time complexity. This question might come to your interview at the very like basic as an introduction part, that what exactly is the time complexity of these three basic algorithms. Well, the time complexity of these three basic algorithms are always going to be big O of n square, where n is size of array. As straightforward as that. Okay, make sure you remember this, because this might come in handy. Well, if you wanted to know about more algorithms, I can just let you know about the names as well, and you can Google it and try to understand them by your own. If you have any doubt, you can simply ask me in any way possible. You can ask your teachers or directly to me as well, whatever way possible to you. Some other algorithms that we have are, first, that is one of the most famous one, are these two. One is quick sort, second is merge sort. These two are most widely used sorting algorithms that we have. These five are going to be more than enough for you to solve 99% of solutions, 99% of questions. But in case you wanted to know about more, there are a couple of more advanced sorting algorithms, but you don't have to worry about all of them, not at all. First five are going to be more than enough, but you can simply get to know about the names as well, so that if you wanted to learn, you can simply Google them and try to understand them by yourself. One is, we have count sort, we have, I think, radix sort as well, etc. There are a couple of more as well. So these are some of the sorting algorithms that you might see in your entire career. But I can simply tell you, these five are going to be more than enough. And to be honest, First three are going to be the most basic ones, as you already aware about it. So let's just get started with the very basic one, the most basic one, which is bubble sort. Here I'm going to tell you the entire dry run of bubble sort algorithms. So make sure to you follow me and use your copy pen as well to write down each and everything while I'm doing the dry run along with me. I will spend a pretty good amount of time in dry running the algorithm, and at the end, you can simply directly understand the code as well. It would be pretty straightforward. Okay, so before starting even the dry run, let me just give you a simple idea of the bubble sort in one single line. Let me just tell you that what exactly we are going to do in this algorithm whenever we are going to do the dry run. Okay, in this what we do is pick the largest element. We always pick the largest element and place it on the rightmost side of unsorted part of array. This is how I understand this algorithm. This is what I have observed and understood. Right now, you're not understanding it. It's all right. Once I do the dry run, you will get to know. We are going to repeat this line again and again many times. Okay. So let's just take a example here of 5 size. Let's just say I'm going to create an array. One, two, three, four, and five. Put some indexing as well. 0, 1, 2, 3, 4. Now any random values we can fill it here. Let's say I use 5, 9, 8, 2, 1. Okay. So what happens in this algorithm is we take multiple iterations for sorting each one of the element. When we are, let's suppose, trying to sort this single element, this 5 only I wanted to sort. So I will traverse the entire array for this particular element. Then I will pick this one, and then I will try to place it on the rightmost side of the unsorted part of the array. As I have just said, I will pick the largest element. See, let me tell you again. What it says is pick the largest element. What I will do is I will pick the largest element and place it on the rightmost side of unsorted array. Okay, once that part is sorted, then I will again pick the next largest element and again place it on the rightmost side. Then I will again pick the next largest element and place it on the rightmost side. Again I will do the same, and again I will do the same. This will, we are hoping that it will solve or sort our array in a proper manner. Let's see if it does that or not. We are going to do this 5 number of times because the size of the array is 5. What you can note right down here is that here we are going to try to divide this array into two parts. One is sorted, one is unsorted. Divides array into two parts, sorted and unsorted. So Basic technique of this algorithm is to swap two elements. This is very important part, to swap two elements. When you try to move each any of the element, you will try to swap it. Let's just see. Let's just do the dry run. Do not worry if it is seems confusing to you right now. Once the dry run is completed, it will be much clearer. Let's say initially in the first iteration, we have our original array 59821. 821. Okay. Now, what we will do here is before starting our process, before starting our dry run, I'm just going to note down here one very important part. That is, here we always work in pairs, in two consecutive pairs. Let's suppose I am standing at the jth index. I am going to consider it as myself, that I am standing at the jth index. And second one will be j plus 1. This one I'm going to consider it as someone else, like someone other than me. Okay. And our entire logic is simply this, that if array of j, that is me, if I am greater than array of j plus 1, if I am greater than someone else, if I am greater than the next element on the right side, then simply swap them. That's all. That's the entire logic that we have in this algorithm. Nothing else you will need ever again. If I am greater than the next element, simply swap. If jth element is greater than j plus 1th element, swap. That's all. Let's see. Let's just try to do that. Let's just assume we are standing right here at the jth index. Am I greater than the next element? No. 5 is not greater than 9. So I will not do anything and I will simply move on to the next one. What happens right now is array looks like same only. We have not done anything. Now, let's suppose right now I'm standing at the ninth element. J is right here. Am I greater than the next element? Well, yes. Right now I am greater than the next element. What I will do is I will simply say swap these two elements. 9 become 8, 8 become 9. Correct? So now, what does our array looks like? Our array looks like this: 5, 8, 9, 2, 1. Correct? Done. Move on to the next one. Just keep on moving to the next one and keep on checking. If I am greater than the next one, then swap. Just stay with me. Stay with me right here. Now I have moved to the next element. Correct? That means initially I was at 5, then I have moved to the next one, then I have moved to the next one. Again, I'm going to check. Am I greater than the next element? Yes. It seems like I am greater than the 2. 9 is greater than 2. So I will simply say swap these two elements. Swap 9 and 2. So now, how does our array looks like? Our array looks like this: 5, 8, 2, 9, 1. Correct? Move to the next one. Let's say we are here and we are checking the next element. Am I greater than the right element? Am I greater than the next element? Well, yes, I can see 9 is greater than 1. So I'm going to say simply swap these two elements. 9 will become 1, 1 will become 9. So now our array is, what does our array looks like? 5, 8, 2, 1, 9. That's all. We have reached till the very end of the array. Now what I will do is, I will simply assume that this much part is now sorted for me. I'm going to assume that this smaller part of the array, only this one element, I'm going to assume that it is already sorted. Now you see the array is divided into two parts. One is unsorted part and one is sorted part. Okay, stay with me. This is one iteration that we have completed. I'm going to say, let's just keep it aside and simply take what exactly is our array looks like here. Now we see our array looks like this: 58219. 58219. Okay, forget about that part. Now we're going to do the operations on this one only, and this much part we have assumed as sorted. Now we have started our second iteration. First iteration was completed. You know that we are going to do the iteration 5 times. Second iteration, exact same thing. No need to worry about anything. Exact same thing. Is your current element greater than the next one? Yes or no? It is not. 5 is not greater than the next element. So our array will remain as it is. 5, 8, 2, 1, 9. Correct? Correct. Move to the next one. Again, I'm going to ask the same thing. Am I greater than the next one? Well, yes, 8 is greater than the next. 8 is greater than 2. So I'm going to say this time we have to swap it. Keep the logic in mind. If current element is greater than the next one, then swap it. So yes, current element is greater than next one. We have swapped it. Done. Now what our arrays looks like? 5, 2, 8, 1, 9. Done. Move to the next one. I'm going to again ask the same question. Is my current element greater than the next one? Well, yes. I can simply say 8 is greater than 1. So I'm going to swap 8 and 1. 8 will become 1 and 1 will become 8. Now what our arrays looks like? 5, 2, 1, 8 and 9. That's it. Done. Now we are going to say second iteration is also completed, and we have assumed now the two elements are sorted. In at the end of first iteration, I have sorted one element. At the end of second iteration, I have sorted the second element as well. Correct? Now let's just talk about the third iteration. What is our current array looks like? 52189. 52189. And we have simply assumed that last two elements are sorted. Correct? Let's just start our third iteration. Again, same thing we are going to do. Every time, same thing only we are going to do. Just tell me, is my current element greater than the next one? Well, yes, 5 is greater than 2. So I'm going to simply swap 5 and 2. And now our array looks like this: 2, 5, 1, 8, and 9. Move to the next one. Again, I will ask the exact same thing. Is my current element greater than the next one? Well, yes, 5 is greater than 1. I'm going to say simply swap these two values. That means exchange these two values. 5 will become 1, 1 will become 5, and our array looks like this now: 2, 5, sorry, 2, 1, 5, 8, and 9. Done. We have reached till the end of the sorted array, unsorted array, and now we have assumed that last three elements are sorted. Very nice. Every time one sorted element is keep getting increased. Now the current element is what? Current array is what? 21589. 21589. And we have assumed that last three elements are already sorted. Start our fourth iteration. Start our fourth iteration. Is my current element greater than the next one? Well, yes. 2 is greater than 1. I'm going to say simply swap these two values. Now our array looks like this: 1, 2, 5, 8, and 9. And that's it. Finished. Now we have assumed last four values are sorted. If you can see properly, this entire array now is sorted because now only one single element is left which we cannot swap with anyone. So that's why this entire array is sorted. Only four times we needed to do the iterations. As you can see, this is the flow that we have taken. Let me just keep this entire dry run in a proper manner. Right here. This is what we have done now. In the first iteration, same thing only. We just keep on swapping if your current element is greater than the next one. In the next one as well, keep on swapping if the current element is greater than the next one. Furthermore, exact same thing. As you can see, every time number of iterations are getting decreased. Here you took 1, 2, 3, 4 operations. Here you took 1, 2, 3 operations. Here you took 1, 2 operation. Here you took only one operation. Because each element is keep on getting sorted, that's why the effort is keep on getting decreased. If you found any difficulty, make sure to watch the video for this dry run one more time. It will make it much more clearer. Now let's just go to the coding part as well for brute force. Coding part as well for the bubble sort. We are going to follow the exact same thing which we have done just now. Now, before actually moving to the coding part, one thing also you might need to know here is every time what we are doing here is in this algorithm is we are swapping two values. You might not know that how do you swap two values, but let me just tell you how do you do that. That is a one entirely separate question, but it's a very small one. It's a very small portion of this actual code, but you definitely need to know how to swap two values. So let me just write down that as well. Na? Here we need to swap two values. Means, let's suppose initially we have a variable a. Initially we have a variable a having value, let's suppose 5, and we have another variable b having value 6. Now what I need to do is I need to swap these two values. I want to have a as 6 and b as 5. How I can do that is there are very simple steps. Only within 3 steps you can simply swap these two values. How do you do that? You can do is you can create a temporary variable int temp. In short, you can say temp. Let's just say I'm going to store a value in the temp. Now what will happen is a value will be transferred to temp. Then what you will do is in next line you will say a value will store the value of b will transfer its value to a, and finally b will have the value of temp. That's it. That's how you can simply swap two values. Let me show you how it is working. Let's suppose you have variable a is equal to 5, you have variable b equal to 6, and you have temp as nothing, initially nothing. Correct? One, two, three steps, one, two, three rows. Once you move a value to temp, a value will remain as it is. It will still be 5 only. B value is totally unchanged. But temp right now is having value of 5. Correct? Because A was 5. In the next line, what will happen? In the next line, A will be containing the value of B. So B value will be transferred to A. A will be 6 now. B is totally unchanged and temp is also totally unchanged. In the next line, temp value will be transferred to B. So A will remain as it is and B value will be changed to whatever the value of temp is. So B value will become 5 and temp is also remain as it is. Now if you can see, after these three steps, initially A was 5 and B was 6. Now A is 6 and B is 5. So now you are 100% sure that yes, this process of three steps are properly swapping two values. This exact same thing we are going to use in this code itself for the bubble sort as well. So let's now just write down the code for bubble sort and also include the swapping code with it. Great. All right then. Let's just clear out the extra code we have. Zoom in a little. Clear everything extra. All right. We have started with inputting the value of an array. Create an array of 5 size having these values. What is the value we have? What is the example we have taken in bubble sort? 59821. 5, okay, sorry, right here, 598 2 and 1. Done. Now I will write down bubble sort. Here I will write down bubble sort algorithm, and at the end I will print the answer, print the array. How do you print the array? Let's just write down the code for printing the array. You will simply traverse from start to end in the array and print each value. Array of I. Done. With some space, let's say. Here. Now here let's just write down the actual algorithm of bubble sort. Okay. First of all, you need to go to the dry run and see how many times, how many iterations are we doing here. 1, 2, as you can see, 1, 2, 3 and 4 iteration. In 4 iteration you are simply be able to solve this question. And why exactly is this 4 only? Because size of your array is 5. Whatever is going to be the size of your array, you will have to iterate one less than that. Always make sure you're writing down these things which I'm saying right now. Whatever is the size of your array, which is 5 right here, you have to do one less iteration to solve it. So let's just write that down. How many times we have to run the loop? One less than the size of array. So I starts from 0. I go until less than array dot length minus 1. One less than the size of array. I plus plus. Now, second important thing to note here is in each iteration. Now focus on each one of the operation. In each iteration, how many operations you have took? Initially, you have took How many operations? 1, 2, 3, 4 operations. Size of the array is 5 and you took only 4 operations. That means you will start from 4 operations. In the next iteration, how many operations you took? 1, 2 and 3. In the next time you will take only 3 operations. What about the next time? You took 1 and 2. Only 2 operations. What about the last time? Last one you will take only 1 operation. That means in every iteration, number of operations are keep getting decreased. How do I write down the loop for that? What I will say is, let's just start the j value from 0. Starting the j value from 0 and go up till array.length minus 1, same only, and also minus I, j plus plus. What will happen here is, every time the I value is getting increased in the first loop, I value is keep on getting increased and j value will be keep on getting decreased with every time. So that's how we achieve it. This is the fixed algorithm. You do not need to change it. You can just not memorize it, but understand it in the exact same way. Whenever someone asks that how exactly bubble sort work, this is exactly how bubble sort works. There is no change in the algorithm. There is no change in the theorem. Here inside you have to simply check uh, if your current element is greater than the next element. That's exactly what we are checking every time, right? If I am greater than the next one, then simply swap two values. Array comma j plus 1. Here we have a swap function. In C++, as I think, we do have a swap function which you can use. But in Java, we need to create a swap algorithm, swap function. Here, I don't think we need it. Let's just see if we are able to run it and it will work. No, it is not working. Some issue is there. Wait a second. Let me check. Array.length is not working in line number 8 right here. Well, I think we do not have parentheses here. Okay, I think instead of length in C++ we use size. Not really. Okay, so what I have observed is we cannot use array.size within the loop while it is changing. So what we can do is we can simply create a separate variable n equal to 5, and then instead of array.size we can use the n value, n variable right here. Okay. Okay. And then in C++, we do have a inbuilt swap function which we can use. Let's just write down that one only. Which two values you want to swap, you can simply write down those two values. ARR square bracket j and ARR square bracket j plus 1. These two values I want to swap. If I run it right now, yes, it is working as expected only according to our input. So yes, it is working fine. All right, let me just write down this code in the notes as well. Here is the code that we have for bubble sort. And time complexity for this code is O of n square. Done. Now we can simply get started with let's just we can simply talk a little bit about the our next topic as well, which is linked list. This is also another data structure which we can use for multiple purposes. What you can do is you can first of all you can imagine it like an array, but it is not like array at all. But it is also used to place elements in a particular manner. But the way of storing the elements, it's a little bit different. That means, let's suppose, what is the difference between an array and a linked list? Let's just assume, first of all, before going to the structure, let me tell you what exactly it actually looks like. Well, your linked list looks something like this. It is going to have one object which is going to store two values. Let's just divide it right here. First part is going to store the value, that what exactly value it is storing. And second part is going to store the address of what exactly? Address of the next element. You will get to know what that is. So let's see. Let's just create the structure of a linked list. What do we call this one particular thing? This one thing is simply called as node. This is one node that we have. One node will always going to contain two values. One is data, we can say, instead of value we can say data. One is data and other one is going to be address. One value is data, other value is going to be address. ठीक है, all right. Data, you are definitely aware about what exactly it is. Any number, any character, any boolean value, any string can be data. As simple as that, what we store in the array as well. Let's say I am storing the value 5 here. Now, what exactly is this address that we are storing here? Well, address is actually the location of the next element that we have. That means it is going to point us to the address of the next node. This is what one single node looks like. Let's suppose next node is storing some value like any random value. Let's suppose 4. Here you will get the address of the further other node. Let's suppose next node is storing some value, let's suppose -2, and the next one will also store the address of the next one. Let's suppose this one is storing value 1. And once the linked list is ended, let's suppose this is the entire linked list we want to create, but once it is ended, what exactly is present here? It will simply point to the value null, or you can say null ptr, null pointer. Once there is no address required, the last address will always be null pointer. This is what the structure of our linked list looks like. That's what a linked list looks like. Each of these nodes are uh, nothing more than the blueprint of a class. That is a very important definition that we have. Once you are going to be familiar with OOPS concepts, this is what small introduction of OOPS is actually. Each node is a reference of a class. Another line you can write down. In this case, class is containing two values which are what exactly I've just told you: data and address of next node. If this somehow seems confusing to you, do not worry about it. Once you will learn more, once you will practice more, we will get to know what exactly these classes means, how these works, and how do we actually create it. We are definitely going to talk about that, how do we create these classes and how these works and what exactly is the structure looks like. Okay, for as of now, I have given you a small introduction of what exactly is a linked list, but it is just getting started. I will tell you a lot more about the linked list. We will practice a couple of questions as well. That is very very important, and I will also tell you the structure of what exactly a linked list class looks like and how do you actually create it. So as of now, we can simply wrap it up right now. But in the next session, we are going to continue from right here only, and we will take it till the very end until you get it very very clear. All right, chalo, ठीक. Thank you.